It is now Lima Time, a program designed to promote the transformation of the agricultural sector for improved income, food and nutrition security. Brought to you by the National Agricultural Information Services, NAIS. Stay abreast with the latest appropriate technologies and policies to increase your production and productivity in crop, nutrition, livestock and fisheries. Lima, moving the agriculture sector forward.
Across Southern Africa, agriculture sustains millions of households, yet plant genetic diversity is under threat due to climate change, environmental degradation, and shrinking crop diversity. When diversity declines, resilience weakens. Responding to this challenge is the SADC Plant Genetic Resources Center, SPGRC. Located 26 kilometers from Lusaka's CBD, SPGRC serves as the regional gene bank for 16 SADC member states. Operating under the SADC's Food, Agriculture and Natural Resources Directorate, it coordinates plant genetic resource conservation and utilization across SADC member states.
The SADC Plant Genetic Resources Center, which is the organization that I'm leading, is responsible for the promotion of conservation and utilization of plant genetic resources for food and agriculture, using modern or appropriate technologies that suit the times of the program, so that we have food and nutrition security guaranteed in the region. Is the coordination of the conservation and the utilization of plant genetic resources for food and agriculture in a sustainable manner in the SADC region. So as we do our work, we work with the SADC member states who at local level, the ones that move around and do the collection and the characterization, documentation of the material from the member states level. They take the material, they put it to the SADC Regional Gene Bank, which is the center that you are seeing here, the SPGRC that I'm leading. So the intention is just to make sure that we have a reserve of plant genetic resources that is available for use by plant breeders or any other researchers in the production of seed that is used in the agriculture by all our farmers every day.
At the heart of SPGRC's work is the germplasm accession, a unique entry representing a distinct plant variety collected at a specific time and place. Each accession is carefully documented. Today, over 78,000 accessions are conserved across the SADC region. Each one represents possibility.
This is the SADC Regional Gene Bank, the base collection for the region. So by base collection, we mean it's where member states duplicate material for long-term storage. So in these freezers you are seeing here, we are storing materials and a total of 24,000 accessions in particular for the long term. The storage temperature is minus 18 degrees Celsius. And these materials have been dried to 3 to 7% moisture content. That moisture content is important because the lower the moisture content the seed has, the longer it stores in the gene bank. So viability checks are done through a germination test, and we have a standard of 85% germination, and if we score less than 85%, it means that accession is going to be planted in the field so that we get new seed which should have higher germination and store for a longer period.
Seeds are cleaned, dried and stored under controlled conditions. Every 5 years, viability is tested. When germination drops below 85%, regeneration takes place. This cycle ensures seeds remain alive, not just stored. All accessions are duplicated at the Svalbard Global Seed Vault in Norway. This provides global insurance against catastrophic loss.
Duplication is a sharing of materials, a copy of materials to the regional gene bank. As you know, the SADC Plant Genetic Resources Center is a regional gene bank with the mandate to conserve or preserve crop diversity from the 16 member states. And this is done as a risk measure for food security, but also agricultural resilience, that is food security and nutritional security for now and the future generations. So how is this duplication or sharing of materials done, of genetic materials? It starts at the national level. The National Plant Genetic Resources Center sends materials to the regional gene bank or the SADC gene bank. So as you know, the SADC gene bank is a network of 16 member states National Plant Genetic Resources Center. So when the materials, for example, cowpea materials are sent to the regional gene bank, a copy of those materials are sent. A copy remains at the national gene bank. When the materials come here, we follow all the procedures of movement of materials. In case they are coming from outside Zambia, we follow all the procedures and the rules of the country. So the import permits are done if they are coming from outside the country, and they will be inspected to make sure that all the rules are followed. And if they are coming from Zambia, still we follow that protocol to make sure that or the rules are followed. So when the materials come here, we test that material, we check the material according to what the member state has indicated to us, what they will be sending to SPGRC.
Conservation must be matched with access to information. SPGRC developed SDIAs to improve data accessibility for researchers, breeders, and policymakers. When information flows freely, innovation thrives.
We use a documentation system called the SDIS, which is short for the SADC Plant Genetic Resources Documentation and Information System. So this is a system that all SADC member states use to manage these materials. So this is an exact system that we have here at regional center, and also which we've deployed in SADC member states. So this system is not just a documentation system per se. We also use it as a gene bank management tool, because all the core activities that involve gene banking are all managed by this system. If you talk about registration of materials from all the places that member states get to collect these materials, from the remotest parts, they use this system to document that information. And if you're talking about managing regeneration activities, managing multiplication activities, all these are in the system, and this is what gene bank managers use. So this is, for us at the SPGRC, this is a very important digital infrastructure, because without this, it will be so hard to manage all these materials. Imagine if you are relying on an Excel sheet to manage these records. It will be almost impossible to do. But with this documentation system, it enables gene bank managers to manage the accessions, the plant genetic resources they have in their respective countries, and also at the regional gene bank. And with this, it's able to inform the gene bankers or the gene bank managers to make informed decision on how the material is performing. Because it is through this system that there will be flags that will pop up for materials that are due for viability, that have been stored for quite a long time. The system will remind the gene bank managers to say, this material is due for viability testing. And then it's also able to assist them to track the quantities, Because remember, at national level, they are mandated to distribute materials. So it's important that they keep in check how much of those species they have in their gene banks. So you need to track quantity, and this system also helps you to track quantity. If you're running low, it will remind you that, oh, this material, you need to take it back to the fields and multiply.
Indigenous crops and forest products are deeply rooted in Zambia's agricultural heritage and rural livelihoods. Across the country, communities rely not only on traditional crops such as sorghum, millet, cowpeas, and bambara groundnuts, but also on forest products that provide essential nutrition and income. Wild foods such as masuku, wild low-cut fruits, chikanda orchids used to prepare chikanda, wild mushrooms, and edible caterpillars such as ithinkuvala are important seasonal foods gathered from forests and woodlands. These resources complement farming systems and contribute to household food security.
There are two types of gene banks. There's a food gene bank for wild fruit trees and medicinal plants. That's the arboretum. And then there's another field gene bank for food of crops for food and agriculture, like sweet potatoes, cassavas, yams. That's a type of field gene bank also. Now the difference, an arboretum is for wild fruit trees and medicinal plants. It's a field gene bank. Okay. Now this field gene bank was established way back in 2006. That's when it was planted out. So in front of you, we have this tree species like Moringa oleifera. It's very rich in vitamin A and C. The leaves can be eaten as a vegetable, and it's got a lot of medicinal properties. Yes. And then the pods, with their light green and soft, they can be eaten like green beans. Then this one is Muchenja, Diospyros kekai. In case you lose your toothbrush in the jungle, in the bush, you can cut off a branch and you can use it for brushing your teeth. And it's a wild fruit tree. The fruit is very nice and it can be used for making jam and juice. Diospyros kekai, Muchenja. And then the scientific name for this one is Musinica, Syzygium guinense. It's very good for making jam and juice. It originates from India and the Mediterranean areas. And then the famous Musica, I'm sure you've heard of Musica. This time it's even commercialized. Scientific name Tamarindus indica. The fruit tastes like a bit like a lemon. It can be made into jam and juice, and this time it's commercially produced into juice. Tamarindus indica Musica. Then I'm sure you've heard of Masao. Ziziphus Mauritania. Masao is eaten like it's a very common fruit in Zambia. It grows in Gwembe Valley and places like that. It's very popular. It's sold at the market. And then there's this one, Oncoba spinosa. It produces round fruits. The seed inside, the traditional dancers tie it around their ankles in form of anklets. When they're dancing, it makes a rattling sound. Check it, check it, check it, check it. Then Kigelia africana, the sausage tree I showed you about. It's very medicinal. It's got a lot of medicinal uses. But it's also used as an aphrodisiac for men. And for agroforestry purposes, this is a very good agroforestry tree. Fadebi albida. Very good for agroforestry, for intercropping in maize, soybeans, even sunflower. The leaves drop and it produces excellent manure. Fadebi albida, Musangu tree.
Over generations, farmers have also preserved landraces, local crop varieties uniquely adapted to Zambia's soils and climate. These varieties are often more resilient to drought, pests, and changing weather patterns. At the national level, scientific research and conservation efforts are led by the Zambia Agricultural Research Institute, ZARI. Its laboratories support crop breeding, seed conservation, plant health diagnostics, and agricultural innovation. To further strengthen research capacity, expansion of research facilities and laboratory buildings is currently underway, enabling scientists to enhance genetic conservation, modernize testing capabilities, and support Zambia's evolving agricultural research needs.
So the Zambia Agricultural Research Institute is the National Plant Genetic Resources Center for Food and Agriculture, where we host the National Gene Bank, whose main purpose is to promote plant diversity from obviously various perspectives. So what we do at the Gene Bank basically is to collect, conserve, and characterize plant genetic resources for food and agriculture. So in our collection at Mount Makulu, we have over 7,000 plant accessions. And of course, we are maintaining these. So for seed accessions, we have them in cold storage facilities. For for vegetative materials, we have these conserved, in the field. The purpose of doing this is so that, one, researchers who are developing varieties can use these accessions as sources of traits to include in their breeding programs. For farmers out there, those who are interested in maintaining plant diversity on their farms, they are also free, to come to Mount Makulu and collect, these genetic resources for their use, in agriculture. Among the other things that we do as a National Gene Bank is we also train communities on how they can, conserve in situ, some of these plant materials or even seeds with a view of promoting plant diversity. Now, ZARI does not work alone because we are a member of a community of practice. And within the sub-region, specifically the SADC, we work through the SADC Plant Genetic Resources Center, which is a regional body, encompassing several SADC countries, that contribute genetic resources, to this pool with a view of increasing genetic resources that are available to various stakeholders within the agriculture sector within the SADC community. So whatever we have here in our gene bank, I must mention, is replicated in the SADC gene bank that is being hosted actually by Zambia. One of the other reasons of having, these genetic resources conserved is in an event that we have, a catastrophic event that, for example, wipes out, the entire gene pool of plant materials that are already commercialized. We can always go back to the gene bank and begin from there. So that is a key reason, of having these genetic resources, these plant genetic resources centers, in various, countries as a way of promoting, plant diversity.
In Gene Bank, aside from cereals and legumes, we also conserve vegetables, African leaf vegetables as we term them, and most of these are commonly known within the local context, or we term them as weeds. We have cleome, which is commonly known as sunta within Zambia. We have wondwe, which is amaranthus. We also have blackjack or Biden's pilosa, which is kanunga. We have all these materials conserved and they're easily accessible to the farmer. We give these materials for free in small distribution packs or in small packets, and we give these to the farmer to go multiply, and all we need from the farmer is simply the feedback on how these materials performed. And the process for them to access these materials is simply to put in a request through our curator or team leader of the National Gene Bank to indicate within that request what they intend to utilize these materials for. It can be for research purposes, it can be for backyard gardening, and just simply for other uses. And this can be done through, of course, through email or through extension services, because we understand that the National Gene Bank is only housed here at Mount Makulu in Chilanga, and sometimes we have requests from farmers as far as Lundazi, as far as areas where most farmers cannot travel to access these materials. So we utilize the services of the extension staff as well as other ZARI research stations that are housed in these provinces. They can simply request through those channels, and that information can simply reach us, and we can also distribute these materials to them through means that will be available for us to ensure that the farmer has access to these materials.
The mission of SPGRC is to mobilize, conserve, and make available plant genetic resources using state-of-the-art technologies. Objectives include reducing genetic erosion, promoting knowledge exchange, strengthening policy environment, and mobilizing sustainable financing.
So the arrangement we have, I would say, is a risk management arrangement. Member states collect material in their countries. They bring it to the SPGRC. SPGRC keeps it as well, but duplicates it again to the so-called global seed vault to ensure that if there is any form of disaster that happens, we are able to start all over again and the humanity continues in our region.
Food security begins with diversity. Resilience begins with foresight. SPGRC stands as a guardian of Southern Africa's agricultural future, because when we protect plant genetic resources, we protect livelihoods, we protect resilience, we protect life itself.